Here we go. Starting chapter 4, antiderivatives. First, if we're going to do antiderivatives, maybe it makes sense to practice some derivatives first. So I have 15, and they should be super fast for you. You can probably, for many of them, just write the answer. But I want you to do these 15 derivatives first. So find the derivative of sine x, find the derivative of cosine. These would be rapid fire at school if we were at school right now. So hit pause and then get an answer for the derivative for each of these. And then I'll pop up the answers and you can check everything and be like, yeah, I know my derivatives. So find the derivative of each of these, hit pause. Here come your solutions. Here they come. I'll write them, it's easier. First one is cosine x. Next one is negative sine x. Next one is 5x to the fourth. Next one is 1 over 2 root x. You might have to rewrite that one. Next one is negative 3 over x to the fourth. That's another one that you might have to rewrite as a negative exponent first. Secant derives to secant x tangent x. E to the x derives to itself. Ln derives to 1 over x. Cotan derives to, this one might be one that you had to actually look up. It is negative cosecant squared x. This one is, 4 times 7 is negative 28 over x to the 8th. Here we go. Next one. Derivative of 3. 3 is a flat line. What's its slope? 0. Derivative of 10. Also a flat line. What's its slope? 0. Derivative of 6. 0. Derivative of 20. 0. You may not know what I was asking for 15. I am asking for the derivative of c, where c is just any old constant. Well, for the same reason that the other 4 were 0, this one is also 0. Hopefully you're cool with that. And that will bounce us into what we're going to do next. So let me give myself some space. I'm going to go right to there. So an antiderivative, sometimes called an integral, is exactly what it sounds like. It is the opposite of derivatives. So today we're just going to focus on the equations for these antiderivatives, and we'll talk about what they mean and what we can do with them as we move further. We'll also make them way more complicated than they are now. The antiderivative, the sign I use is that like wavy stretched, vertically stretched S. It's an integral sign. And then I write 5x to the fourth, and I put a dx there. For now, you'll just think of the dx as being, it tells me what we're integrating with respect to. So it's just telling me x is my variable. We'll talk more about it later and what it means and why it's there. But for now, let's just pump some equations and practice and make sure we're good with this. So the integral, and sorry, this integral sign here is we usually make it a little bit taller than all of the rest of the writing in here. So, and I integrate what is between the integral and the dx. All right. So what is this? Well, look, didn't we just say that x to the fifth derives to 5x to the fourth? If I want to do an antiderivative, then if I antiderive this, I should get that. And that's exactly what we get. The integral of 5x to the fourth is x to the fifth. And that's because this would be the derivative operation. So an antiderivative would be that move right there. Now, that's not quite the entire answer. There is also a plus c. Why is that? Well, if we look up here, this derived to 0, 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 any constant derives to 0. So the derivative with respect to x of a constant is 0. Why is that? Because I could draw c as my y value and make it flat, right? And what's the slope of this? M is equal to 0, right? So the derivative of any constant is just 0. that means that the integral would work the other way, right? So if this is a dir, notice it's the opposite here, then the antiderivative, or the integral of 0, would be c. So let me write that. The integral of 0 dx is equal to a constant. Now, maybe you can see why that what that has to do with this. But look, couldn't I write the integral of 5x to the fourth as the integral of 5x to the fourth plus nothing dx? There's like a set of parentheses like that that's sort of implied. I could, right? Because that's exactly the same as what I have here. So what do I get? Well, what would derive to 5x to the fourth? The answer would be x to the fifth. And what would derive to 0? Plus a constant. So hopefully that helps you see why we have a plus c anytime we do an integral. Well, this type of integral. We'll talk about other ones later, although they sort of have it anyway. So let's try another one. Let's do the integral of -3 over x to the fourth. Let's go up a little bit. Ooh, that one's right here. Didn't that come from this? It did. So our answer should be 1 over x cubed plus c. But let me show you how we get there. So this is the same as, with a dx. Sometimes I forget them. The integral of 3 times x to the -4th dx, which is, all right, what we're going to do is go up a power from -4. That takes me to x to the -3. And I will explain this with a positive exponent in a moment, and it might make a little bit more sense. But I go up to -3 from this -4 right here. And then, and I lost that, I write my -3. That -3 is this -3. But then what I need to do is divide. I need to divide by this, so you can't see it, this right here. So I divide by -3. And that gives me, these guys cancel, 1 over x cubed. And I should write my plus c, and I should write my plus c. So let me try to make a little bit more sense of that with a equation that is a little bit more simple. So to see it, let's do the derivative with respect to x of, I'm going to go 7 times x to the fifth. Well, there are two steps here when we do this power rule. I multiply, and then the next step I do is reduce. What I mean by that is I take the 7 and I multiply that by this power, 5, and then I write my x, and then I reduce the 5 by 1 power and get 4. So when I simplify that, I get 35 times x to the fourth. So if a power rule for a derivative is multiply and reduce, power rule for an integral or an antiderivative is going to be the opposite operations in the opposite order. So we are going to increase, and then we're going to divide. Not to get too mathy, but back when you learned how to do inverse functions in like algebra 2 and whatever, it was always the opposite operations in the opposite order. This is totally the same thing. This is an integral and a derivative are inverse operations. So if a derivative for power rule is multiply and then reduce, then we do the opposite, increase, and then divide in the opposite order. So what does that give me for this one? Integral of 12x squared dx. Well, I'm going to just write my 12. It comes along for the ride just like they do in derivatives. I'm going to write my x. I'm going to increase so that x squared gets increased to x cubed. And then I'm going to divide. divided by my new power, 3, plus a constant, which gives me 12 divided by 3 is 4x cubed plus c. So hopefully you see how to do power rule, you see what an antiderivative is, and you see that you can do them moderately quickly. It's just going backwards from what you've already learned how to do. And we're not doing any chain rule or anything like that yet, so you don't have to think that hard for that stuff. So hopefully you're good with this. I'm going to give you some con. Thank you. You're doing an awesome job. Keep it up. You rock. See ya.